Alright, welcome back to another day of Advent of Code, and today we are going to try and solve day 9 disk fragmenter. And the idea today is that we walk into these amphipods from like 3 years ago, and they are trying to work with some computers and they have some problems fragmenting their disk. So we get a disk map, and this disk map is also our puzzle input, and it shows us some numbers, obviously, and these numbers contain the layout of files and free space. So how does this work is that the odd indices are gonna be files and the even indices are gonna be empty spaces. So again, a disk map that looks like this, 1 2 3 4 5, what does it mean is that we have a file of size 1, then an empty space of size 2, a file of size 3, an empty space of size 4, and then a file of size 5, right? So I think you can kind of see where this is going. So what we want to do is to simulate this disk, and I've tried already to solve it with a different, like not simulating, but I think that simulating should be easy enough. So yeah, and what we are gonna do is basically so they also give us the algorithm of how the simulation should work. So it tells us that the files that are at the beginning, they are fine, we don't do anything with them, but when we get empty space, we need to take blocks from the end. So for instance, we take these two 2s and we place them here, then we leave the 1s as they are, and then we move all these 2s in the empty space. So that's the idea. So what I'm gonna do is have a really big array, and when we get to odd index, we just copy its index multiple times there, like size times, and when we get to an even index, we get the item from the back and we fill it in, right? That's the idea. We just have to make sure that the last item, so for instance here with the 2, so here it says with the example above, right? So we take the last one and we place it here, we take the last one and we place it right here. All right, and so on and so forth. Okay, makes sense. Well, I mean, question is, I know, I mean, we can try to just do it in one single step. So let's try to implement it, and for the implementation, I'm actually gonna use Rust. I already have the read input function, but let's do the parsing and the part 1 solution together. So yeah, let's get right into it. Okay, so to parse the input, we are gonna get a string. Actually, I can just say str, and we are gonna return a vec of usize. All right, so I'm gonna do input.chars, and then we can filter map a single character, we convert it to digit, right? And this thing returns optional, so that's why I want to do a filter map to get rid of the ones that error. Shouldn't be any, but who knows. All right, and then we collect into, wait, oh yeah, another thing I want to do is here, let's map this digit as usize. So we want to convert it to usize. And the reason why is that we have really big numbers in the end. Like right now they are digits, but they are gonna add up together. So yeah. Okay, so we have let input is equal to read input, and then we are gonna do let disk is equal to parse input, and here we just pass the input in. All right, so let result part 1, we pass it the disk. So let's create this function part 1, and it's gonna take in a disk vacuum size, and it should return just usize number. So we'll have the result. Let's just put here like 0, and let's try to run it. So yeah, if we run it on the input, we just get 0. Okay, so what I'm actually gonna do is have a really big memory, let's call it. I mean, it's still the disk, but yeah, which is gonna be a vec of usize, and initially is gonna be empty, I think. Okay, so let's try to iterate our for index in 0 up to disk dot length, right? And as I said, if we have, like, if I is even, it's odd, then we have a file, otherwise we have an empty space. So how is this thing gonna work? Well, I would like to make it in one step ideally, but we'll see if that's possible. Or maybe, what if we do option here? Oh shit. Option, and like if it's even, we just add the number, and if it's odd, we just add nuns, and then we simulate it exactly as they show in the example. So that's maybe gonna be much easier to do, and we'll see if we need any optimizations, but for now let's just do that. So if the index is, let me just say, size is equal to disk of I. So if the index is odd, then we have a file, which means that we have to just paste in the number. Well, I guess we have to paste in a file ID. So let index is equal to 0 is going to be the file ID, or file ID. Well, I mean, file ID is I divided by 2, but you get the point. So I'm gonna do something like for something in 0 up to size, I'm just gonna say memory dot push some file ID, right? And if it's odd, I'm gonna push none, right? And here let's return 0 or something. And yeah, anyway, this should be mutable. Perfect. So let's try to print here, print ln. Let's show our, the fuck, memory. Sometimes it do be like that. So let's paste in the example. So we have like It's actually the other way around. If it's 0, I was putting the other stuff. Okay, and also let's not forget about file ID incrementing by 1. So it should be mutable. So we get 0, 0, 1, 3 times. So it's like this example right here, right? We have nones, we have some, 2, and then so on and so forth. So now what we have to do is to simulate the exact process that they describe here. So how are we gonna do that? Is iterate through the memory. So we have to do something, we have to do something like for I in 0 up until memory dot length. All right, this is the index. So if we encounter like a none, we want to replace it with the last element, right? That's what we want to do. Hopefully it works in Rust to do that. So if memory of I is none, then what I want to do is memory I is equal to, basically I want to do memory dot pop, and I want to unwrap because this returns option T. Like pop itself can fail, so that's why I have to unwrap. So it's going to be an option of options, right? Like if I do memory dot pop and say let a is equal to, it's going to say option use size, so I have to unwrap once. So that's, I think, the simulation. The len is 30, but the index is 30 as well. Should I just say -1 here? Wait. The len is 30, but the index is 30. But if I say -1 there, I guess it doesn't know how to update that thing. So how should we do it then? I guess I could just loop let mutable index is equal to 0, and here we have index plus equals to 1, but this is like unreachable. So I have to say if index is greater than memory.len, we just break, right? I can do that, so hopefully, let's see. No, what the fuck? Is greater or equal? Yeah, I guess so. So in the end we are getting 0, 0, 9, 9, 8, 1, 1, 1, 8, 8, 8, and at the end it's 5, 6, 6, 6. Oh shit. I have some none here. So if memory index is none, then I set it. So why does it... Wait. memory index. Wait. So here it's like 744. It's not even 744. Whoops. What did I do wrong? It's a good question. So 00998811 3 8s, a 2, and then it broke. It's funny. Wait, what the fuck? It's really weird. Like, how does the index become greater than memory length? Well, you know, like, easiest other way to do it is to just imagine that no, but it doesn't work. Yeah, I see. It's because if we pop, we could pop into empty. Okay, so I see why it could happen. So here when we pop, we need to make sure that we pop until we find the real number. So let number, or like yes, let file ID. Actually, it's size. No, it's file ID. We want to pop, right? And while I guess I could say let sum. No. While file ID dot is none, we want to pop more, and then set file ID here. Right, like that. I think that's you just need to pop more. So 566. Yeah, this looks kind of right. So we are kind of sure now at the end that memory is equal to memory dot iter dot map a. So this is the option dot unwrap collect. So what is this? Well, it's a vector view size. So now we should see 00999 8111 888 277. Yeah, it looks fine. Now I'm curious about the day 09. Okay, so I was a dummy dumb and I really thought that it's gonna be slow. Okay, fair enough. So what do we have to do with these numbers is just enumerate and multiply with the index. So I could just say here enumerate, and then no, let's put them like this because we are cool Rust developers. So here is gonna be fold, just fold, starts with 0, accumulator, index and file ID, index and file ID. And what do I want to do is accumulator plus I times file ID. So this is total Okay, and no, my problem was I still have the wrong input. That's funny. This was what I got, and this is what we have now, which is much bigger. Yeah, I'm not sure. So why that one? Wait, I didn't even check the temporary, but I mean, I was pretty sure it's gonna work because yeah, we just brute forced it basically. I'd like to try and do this one with the algorithm that I was thinking about, like not having to expand everything. That would be much cooler, but it is what it is. If brute force works, then brute force works. So let's see what part 2 is about. Okay, so upon completion, two things immediately become clear. First, the disk definitely has a lot more contiguous free space, just like the amphipode hoped. So we have a lot of free space at the end. Second, the computer is running much more slowly, maybe because we have a lot of fragmentation. So we have a lot of fragmented files. Oh my god, we have to sort them, right? The eager amphipode already has a plan. Rather than move individual blocks, he'd like to try compacting the files on his disk by moving the whole files. So we have to fill in gaps with files. Okay, so let's see if they give us an algorithm. This time attempt to move the whole file to the leftmost span of free space block that could fit the file. So let's say I guess this makes me think that we still start from the end. So it's like a free space that could fit the file. Attempt to move each file exactly once in order of decreasing file ID number, starting with the file with the highest file ID number. If there is no span of free space to the left, the file does not move. For example, we take 99 and we move it here, then we take 888, but 888 doesn't fit anywhere, so we take 777 instead. Okay, and we move it where it fits. Then we take 666, but this one doesn't move. 555 doesn't move either, so then we can just move 444, right? And then what's interesting is that we don't go back and move 888 into this space, right? So we just stop. So the process of updating the file system checksum is the same. Now this example checksum would be like this. So when we simulate the thingy, I guess what do I want to do with this? So for part 2, let's start with part 2, right? So for part 2, I'm gonna have function part 2. It's also gonna take a disk usize, and it's gonna return usize. So let's just have you know what's the problem here? I want to send a reference and here a reference as well, because I want to not have to copy it, because I'm not going to change the disk. All right, yeah. So let's leave part 1 as it is, because I don't really care about it. But for part 2, maybe instead of this thing, we want could make sense to have a so what I kind of want to do is have an enum enum block, because that's a continuous block, it says. I mean, block is just okay, I'm gonna call it chunk, and chunk can be either empty and it's gonna have a size, so we use size, or it can be filled and it should have file ID, which is going to be your size, and its size. So I think I want to have it like this. So it's going to be either empty, and we are going to have how big it can be, and filled, which is file ID and the file ID and the size of that file. All right. So what are we gonna do now? Instead of this, I'm gonna say here, well, it's a vec of chunks. Return 0. And I'm just gonna simulate the thing afterwards, but for now we are just gonna do the chunks. So again, we have the same kind of for loop. I would say it's similar. So we go like this, we take the size, and if it's like this, we just push field, chunk field, file ID, and size, but we just push it once. File ID and size. And if it is empty, we just push the size. Right. And what do we have to do now? Is we could start from that, so we don't care that these free spaces are going to be fragmented. Like, that's not important. What's important is to split this free space into the right thingies. So I think also while loop like this makes sense. So we are gonna do a while loop, and we should start maybe from the end, or we should just start from the beginning. Right, we start from the beginning. Okay, we start from the beginning, and here we are doing something like a case, or is it match memory index, and we have two cases. Oh yeah, whatever, match memory index. We have empty with a size, and here we have file ID, size to do. Right, we have these two cases. So if we have a field thing, we don't do anything because we don't care. So how do I say nothing? I guess like that. And if we have an empty cell, right, I want to do something similar to this thing. So we do memory pop, unwrap, and we take let chunk is equal to, and here we do while I guess I could have something like impl chunk is empty. Do I have like self boolean return, or I guess while chunk that is empty. So while it's an empty chunk, we do the same thing. Okay, without the mute, obviously. And what do we have to do? But yeah, this doesn't work. I need specifically an index for the end as well. So let's not do pops. Let's do something like let mute moved is equal to shit. It's gonna be the index of the last stuff. But see here, for instance, no, like I just have to move from the end and that's it. Right, I don't have to do something different. But having two indices still makes sense. One will be for where I want to move, and one of them is gonna be what do I want to move. Right. So let's think about it. So we have an if we cannot push, so it says that first the leftmost span of free space. But you know what's weird? To move whole files to the leftmost span of free space that could fit the block. So we start with the last one and we check from left to right if we can move it. Okay, so we don't even need this one. Makes sense. So we are gonna check every time that we can move it or not. So I would say then it's memory dot len -1. Okay. So we could do something like, okay, how do I make this function working? Self match self shit. Let's remove this thing. Okay, I have to say okay. So if it's empty, it's true, otherwise it's false. Okay, simple. Perfect. So now I can do something like while memory index dot is empty. The fuck is empty? I do index -1. So we just moved on the first block that we can move actually. So let's have now a loop. Shit. A loop, and inside of this loop we are going to pick our item. So where I'm gonna say let chunk is equal to memory index. So maybe even this thing should be while index is greater or equal to 0, but I mean, it's while it's greater than 0, it's fine. Okay, whatever, let's borrow. So that way we get the chunk, right? Well, it doesn't, I mean, I might as well just do the same thing here and not worry about it. So while the index is greater than 0, we do this stuff. Right, and here if index is equal to 0, we can just break. So yeah, this could be a loop. Maybe here and index is greater than 0. Oh, while loop. Okay, loop. Perfect. So what should we do next? Well, we know that the memory is not empty, so we need to iterate from the beginning and find a space where it can fit. Let size is equal to memory of index. Okay, let's do let if let, which is the only case that can happen. So if we find the filled chunk, we need to start an iteration from the beginning, right? Which, I mean, it's a bit annoying, but it is what it is. So what am I gonna do? So we have to think about this one, because if we insert 99, for instance, in here, we are gonna split this into two chunks. We are gonna have a chunk with 99, so we move it basically, and the other chunk is gonna be the remaining free space, which is maybe it's gonna be 0, maybe it's gonna be 1, maybe it's gonna be 2, and yeah, you know. So let's do a while. So let mutable free index. So it wants the leftmost one that can fit. The leftmost one that can fit. So this means that I have to do something like while free index is less than index, because if we go past index, it's no longer leftmost. It's kind of too far away, let's say. So while this thing can happen, if, and maybe I can also have let mutable found is equal to false if memory free index is empty. I guess if let chunks empty, free size, maybe I can even say and free size is greater or equal than size. Let's even oh, is it n? No. Oh, memory, yeah, memory of free index, and the free size is whatever, doesn't like that. If free size is greater than, then found is equal to true, and we break. And we also got the free index, right, that we can move to free index. So what am I gonna do then? Well, maybe I don't even need this check, I just need a break. So what I'm gonna do actually is say something like memory.insert. We want to insert our chunk. So we want to insert at free index. We want to insert, can I say just memory index? Is it gonna yell? Okay. Cannot I do something like this? So what do I want to do is basically just copy my chunk at that position, but what do I want to do as well is memory of free index is chunk empty free size minus size. So we make the size smaller if the free size is enough, and then we insert, and maybe even before that I want to do something like let chunk is equal to memory remove index, and chunk is chunk. So here I can actually just put chunk there, and then we break. And as I said, I don't think I need free index. I need to increment here free index plus equals to 1. So that's my idea here. Alright, we start from the end. Index is equal to length minus 1. While we have empties, we move to the left. Right, we found an index that is filled, so we take that file, we do something like free index, and then while free index is smaller than the index, we do that. But yeah, that's true. If I don't find an empty spot, then I have to decrease the index. So found was useful. Let mutable found is equal to false. Oops. Found is equal with true. And here at the end, after the while loop, if not found, then index minus equals to 1. Which I think that should actually do it, hopefully. And then we can have this memory thingy that we can actually break. So I can even have let disk is equal to memory just to save it, and then we can just match disk I All right, and we can have empty size file ID size, and here we have two options. Here we have two options. One of them is this. So if we have empty, then we push nones for the entire size. If we have that, we push some file ID. All right, and I don't need that. And then we don't even need to run any algorithm. All right, we just need to do something like this. I want just to visualize the memory first. So println memory. Let's see if it actually does anything. So 0099 some 2, then it's 11177. Yo, that's actually impressive. 77, but then is an empty space. Or for empty 333. Nice. Then it's multiple nones though. 4 5s, yeah. 4 6s, and then 4 8s. So what's the problem with the empty space? Right, the free size doesn't really work. Why is that? Why is the free size not working? Ah, shit. Why is the free size not working? Let's do a break right after the first call. So it says 0099 and then a none. Right, so at this point it looks correct. The 2, perfect, it looks fine. Oh, what did I delete? Okay. We override the index somehow. Where is it defined? No, wait, are you stupid? What do you mean? Ah, it's because of this break. Wow, I mean the compiler is pretty nice with these kind of errors. But why do we get this stupid ass error? Right, I'd like to have something like memory, but use it inside of that. So no, it's like chunks. let's do chunks, and let's try to print it after each iteration, right? Ah, shit, it looks like shit. Okay, maybe we can even make it a bit better looking by doing something like chunks, let chunks iter collect, and it's gonna still be vec view size. But I don't want to unwrap. I want to say unwrap or 69 or something. So we get like 0099, 69 the empty space, 11, then the empty spaces. Then for the second iteration, 88 doesn't work to move, so it should be the exact same thing. Then we try to move the 7s, and the 7s should come here. Right. 7s should be there. And what between the, yeah, so it's only 2 empty spaces here. Then is the 666, which doesn't work as well. Then is the 555, which doesn't work. And then comes the 4s. And the 4s should come right after the 2. And then we have a 69 after the 4s. And then 3s, 260. So after the 3s, we had, oh shit, I forgot about that. It's actually, we actually have to, yeah, I see it now. So when we remove the index, we don't want to remove it. We actually want to replace that with an empty chunk of size. So I want to do something like memory index is equal to chunk empty of size, right? So that's what I want to do. And then it was a good idea. Chunk is equal to memory index dot clone, right? But now comes the other problem, because the index has moved, right? The index has moved. But is it a problem though? Let's see. So no, I'd like to show it as a string, the command. Let's do it as a string. So unwrap or 69. No, let's do it as a string. O match O so if we have some O, we do O dot to string, and otherwise we put empty string. Oh shit, to string as well, whatever. And this is gonna be a vec of string, but I want to combine everything into a single string. So now it should be exactly like it looked on that trash. Okay, I'm just kidding. So here we moved the 9s, then we cannot move the 8s, but then we move the 7s, cannot move the 6s, we cannot move the 5s, we can move the 4s, then 3s don't do anything, and nothing can be moved anymore, right? Even though if we try. Nice. So that's that, I guess. Which is gonna make it slower, but who cares? Like, let's see if so this actually runs, and if we try to run it on our input, it's a bit slow, but let's see. It's a bit slow, but let's see. So here, unwrap or 0, because wait, what? Wait. Oh no, on chunks. On chunks. Unwrap or 0. Right, because the file ID is gonna be 0 if it's empty. It's gonna be 0 if it's empty, so I think it makes sense. Because we want to... Huh, interesting. It actually worked. Nice. So yeah, why do we also keep the empty file IDs? Because we want to increment our chunk index. Like you can see here, these are empty chunks, but you still have to increment the chunk ID. So I mean, that's honestly, it looks like trash, the code, but probably it could be done more beautiful. But you know, I like to program in Rust. Like you literally imagine like a place filled with rust and trash. It makes it more fun when you don't know what's gonna happen, and it's like that kind of language. When it compiles, it works, so you don't even have to worry that much about stuff. But obviously, like, we could make it fancier, especially if we use enums and the first part we do it the same. We can reuse this thing, we can reuse like a lot of stuff from one part to the other. But I mean, I guess that's it for today. We managed to do day 9 in Rust. It was a pretty fun day, to be honest. Like this stuff with moving things around, it's gonna be nice to do the simulation for this one. I'm really curious if I'm gonna be able to implement something like that, to like visualization. But yeah, that's everything for today. Hopefully it was useful, and we'll see tomorrow with the next day. So see you.